Okay, so here's the problem. The figure shows a two-member truss supporting a block of weight W. The cross-sectional areas of the members are 846 square millimeter for AB and 380 square millimeter for AC. We are to determine the maximum safe value of W if the working stresses are 111 megapascal for AB and 122 megapascal for AC. Okay, so how do we approach this problem? Okay, so given yung cross-sectional areas ng members, also given then yung working stresses ng members, better we solve first for the value of the force, the allowable force for AB and AC. From the formula for stress, which is equal to force over area, from this formula, we can derive that the force is equal to the stress times area. So for member AB, in solving for the value of the force or the allowable force, that's just equal to 111 megapascal multiplied by the cross-sectional area of the member, which is 846 square millimeter. And the resulting force is 93.906 kilonewton. So yun yung allowable force for AB. Solving for the allowable force for AC, same formula. The force is just equal to stress times area. Yung allowable stress for AC, that is 122 megapascal. At saka yung cross-sectional area niya, which is 380 square millimeter. Now, solving for the value of the force, that is 46.36 kilonewton. Yun yung allowable force for AC. Now, since you already have the value of the allowable forces for AB and AC, of course, we have to draw the free body diagram first. One of the common mistake na ginagawa ng student is this. Gagamitin yung value ng maximum allowable force ng AB at saka ng AC doon sa free body diagram like this. This is wrong because hindi naman simultaneously na ma-reach ng AB at saka ng AC yung capacity nila. So, we cannot do this. What we can do instead is to solve for W using the maximum allowable force for AB and solve it again using the maximum allowable force for AC. So we will do that here. What we can do first is to draw the force polygon of the free body diagram like this. Of course, we have to identify the angles, the interior angles for this triangle, for this polygon. And since these angles are the same, so we can just put 60 here. So this is 100. And here, this is 30. And at the top angle is 50. Okay, so this is our force polygon. Now, we can solve now for the value of W using the maximum allowable force for AB using sine law. Now, from sine law, we can create this equation. W over sine 100 is equal to AB over sine 30. Substituting the value for AB, we can solve now for the value of W, and that is 184.959 kilonewton. So this is the value of W using the maximum allowable force at AB. We will also solve for the maximum allowable force for AC. Okay, we'll also use sine law, and this time we'll be using the value for AC. Okay, now, so from sine law, we'll be able to create this equation, W over sine 100 is equal to AC over sine 50. Yon. Then we will substitute the value of AC to the equation. We'll be able to solve the value of W, which is 59.599 kilonewton. So this is now the value of W using the maximum allowable force at AC. Now, we were able to solve two values for W. And since yung hinahanap naman is yung maximum safe value ng W, we'll be using the safest among the two values. And that is 59.599 kilonewton.